The circle C with centre A, B and radius 5 touches the x-axis at the point 4, 0, as shown in the diagram above. Part A, write down the value of A and the value of B. So the fact that the circle touches at the coordinate 4, 0, that's telling me that this line here, the x-axis, is a tangent to the circle. And therefore it is perpendicular to the radius. So that's telling me then that this height here is 5 because it's the radius, which is telling me that B must be 5. If this length here is 5, then the y coordinate of this point must be 5. Even more than that, this radius is perpendicular to the x-axis, which means that if this is 4, then this is 4 as well. So therefore A must be 4. So the centre of the circle is the point 4, 5. So A is 4, B is 5 for part A of the question. We can now find the Cartesian equation of the circle. Remember, the Cartesian equation of the circle is x minus the x coordinate of the centre, all squared, plus y minus the y coordinate of the centre, all squared, equals the radius squared. And the radius is 5 in this case, so 5 squared is 25. That's the Cartesian equation of the circle. Right, we're then told that a tangent to the circle drawn from the point P, which has got the coordinate 8, 17. Now it is worth just thinking just for a moment whether the point where the point 8, 17 is going to be. And I think roughly it's going to be up here somewhere. It's certainly not on the circle because we can't draw a tangent from a point on the circle to the circle. And also you could, if you wanted to, substitute 8 and 17 in here and you would see that you get a number bigger than 25. So we know that point 8, 17 is not on the circle. So I've just put it roughly up there for now. And I'm going to draw a tangent from that point to the circle. So let me get a straight line to help me draw this tangent. From point P going through this, touching the circle. Now I could draw it here. Oops, wrong pen. So I could draw my tangent here like this, or I could draw my tangent here like this. It doesn't really matter. We know from circle theorems at GCSE that this length is going to be equal to this length, so it doesn't matter which way round you do it, really. So I'm going to work out the first one. So there's my tangent, and it touches the circle at point T. So this is my point T here. Now the key thing about a tangent to a circle is that it meets the radius at 90 degrees. So I'm going to mark on my radius at 90 degrees here. And I know that the radius of the circle is 5. I want to work out the length of PT, this length here. Now, I can't work that out directly yet, but I can work out the distance between point P and the centre of the circle because I know both of those coordinates. And if I work out this length, then I can do a little bit of Pythagoras to work out PT. So let's work out this green length, the distance between point P and the centre of the circle. We know their coordinates, so let's do the change in the x coordinates squared plus the change in the y coordinates squared, all square rooted. So if I do that, I get 4 squared plus 12 squared, which is 16 plus 144, or the square root of 160. So this green line is root 160. I can now do some Pythagoras here because I know the hypotenuse of this triangle. I know the green length here is 160. Oh, sorry, root 160. I know this side here is 5, so we can now work out the length PT. A little bit of Pythagoras. PT squared is going to be equal to the hypotenuse squared minus the 5 squared. So 160 minus 25 is 130. Square root that, and we get 11.6 to 3 significant figures. And that's the length of PT.